In this video we are going to show you how to use the new features of EcoBoost and battery threshold settings for your Wattpilot device. So why have we done these settings? First of all, some customers, they want to raise up their consumption values for the stationary battery system. And we have come to the conclusion that in the summer months, the battery system, the stationary battery system, is often over-dimensioned. So for this reason, we have come up with the features of EcoBoost functionality and thresholds for the battery setting. So how can you use these new features? First of all, please make sure to have the firmware version 41.7 on your Wattpilot device, as well as the Solar Wattpilot version 1.9.36 on your smartphone. With these two firmware versions and software settings, you are now able to activate the boost functionality and the thresholds for the battery settings. Please note, however, this is not a possibility to prevent the stationary battery from being discharged. So this is not use of it. The whole use of it is to make sure that you can best use your system and make sure to have a good usage of your stationary battery system. Yeah, first of all, let's start with the first variant, with the first version, and this is called the EcoBoost feature. And how you can use this EcoBoost feature, I want to show you directly in our FRONIUS Solar Wattpilot app. First of all, we start the Wattpilot app with our landing page, and there down below you can instantly see the boost functionality in your app. Please note, however, this boost functionality is only available when you have connected a battery system to your system, and then you can activate the boost functionality. First of all, you can activate the boost function with this little switch here, and down below you will find the point settings. Here in settings you can now configure your functionality. First of all, the first value is called Discharge Until, and this means that this is the value where your stationary battery system will be discharged to charge your electric vehicle. So in our first case, we say we want to discharge until 20% state of charge of this stationary battery. You have then the possibility to alternate between one time and repeat as long as the vehicle is being plugged in. So this means that you can either decide to have this behavior once and then it should stop. So that means that your vehicle will be charged until the SOC of the stationary battery will reach 20%, and then the behavior will stop and will not go on anymore. This you can use, for example, when you're not sure to leave the house. So for example, when you're not sure that you will leave the house later on, you can make sure that this behavior will be only set once and then it will stop. Afterwards, you have the second possibility, and you can make sure that the behavior is being repeated as long as the vehicle is being plugged in. So that means, for example, you stay at home during the day and you want to make sure that your PV surplus energy is not being charged into the battery system, but it is being charged in your electric vehicle. So therefore you can choose repeat as long as vehicle is being plugged in, and that means that the state of charge of 20% is being set and is being hold of the PV battery system, and then the vehicle is being charged on a continuously basis. Please also make sure that we have a threshold of 5% to prevent the electric vehicle from being start and stopped by the charging process or during the charging process. So that means that the PV system will wait until the battery threshold of the stationary system is, in our case, 25%, and then it will recharge the electric vehicle and start the charging process again. So this should prevent an on-off behavior of the electric vehicle. When you have done the settings, please hit the Save button to save your settings. This is really important so that the Wattpilot will do the new behavior. The second functionality that I want to show you is the so-called PV stationary thresholds. And with these thresholds, you have now the possibility to raise up the values for your stationary battery and to make sure that you get best usage of your system. To activate this, we go into the point settings, and then we can go into the point cost optimization. When you scroll down this page of cost optimization, you will find the point PV battery threshold. Here you can now configure the behavior of your PV system and of the stationary system. First point is vehicle charges from, and then a percentage. And here you can set your own percentage when you want to make sure that the Wattpilot or the electric vehicle gets energy from the system. So in our first case, we are putting this value to 70%. So that means that the stationary battery system needs to be charged from the PV surplus energy until 70% state of charge. And after that, when this value is reached, the Wattpilot and therefore the electric vehicle will get energy from the PV system to make sure that the vehicle is being charged. So this can be the case, for example, when you want to make sure that your PV system or stationary system is being charged to a specific SOC, that you have enough energy, for example, for the nighttime loads. Second feature is then the discharge functionality of the PV battery. And therefore you can set now a discharge value, and in our case we are setting this value to 50%, since you know, for example, that you need at least 50% of your stationary battery to go out throughout the nighttime. So this means with this 50% you have enough energy for the nighttime loads to make sure that they can be supplied with PV surplus energy without the need of drawing energy from the public grid. So with these two values, this is what you can now see in our schematic here. The stationary PV battery will be charged until the value of 70%, and then the vehicle will use the charge of the PV battery to charge until our down value of 50%. So in this case, at 50%, the discharging will stop, and the battery capacity of 50% is reserved then for the nighttime loads. And then on the right hand side of the schematic, you see that this energy is being used then for the nighttime loads to supply the household in the nighttime. This is the first example, and the second example is now also to use time thresholds for your charging and discharging behavior. So in this case, besides of the SOC limits, you can also set a time limit for your system. So that means in our second example, for example, we give it a value of vehicle charges from 10%. So that means that at the SOC of 10% of the stationary battery system, the vehicle gets the charge. After that, we are setting a discharge of the PV battery to 20%. So that means that the vehicle is able to discharge the stationary battery until 20%. And last but not least, we are setting a time limit when this should happen. And for example, in our first example, we are setting here 4 a.m. in the morning until 8 a.m. in the morning. And this comes, for example, because the customer knows he needs to leave the house at 8 a.m. and wants to make sure that his stationary battery is being discharged to a lowest possible value so that it is then ready for the next day to take on the energy from the PV system. And this is what you can see now in the schematic. You see on the left-hand side, battery in the morning hours is still at 60%, relatively high state of charge. Therefore, at 4 a.m. in the morning, the battery of the vehicle is being charged with the energy that is still left in the stationary battery. And it is being discharged until 20% to have a state of charge left for the rest of the nighttime hours. And then the battery is being discharged until the morning hours and then is being charged again with the help of PV surplus energy. So that means that you can use your stationary system on a better basis so that you can use the capacity of your system throughout the day and to make sure to make use of this energy that you produced during the processor day. So I hope this was helpful for you, and I wish you all the best with this new functionality to use the EcoBoost functionality as well as the thresholds for your PV battery system.